This is SpaceTime, Series 23, Episode 130. Coming up on SpaceTime, the Large Magellanic Cloud's violent encounter with the Milky Way, Washington launches a new top-secret spy satellite, and the ticking time bomb known as Eta Carinae. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has found that a neighbouring galaxy called the Large Magellanic Cloud is twisting and deforming the disk of the Milky Way Galaxy. It seems the spiral-shaped disk of stars and planets which characterise our Milky Way Galaxy is being pulled and torn with extreme violence by the gravitational force of the nearby Large Magellanic Cloud. The Large and Small Magellanic Clouds are a pair of satellite dwarf galaxies of our own galaxy, the Milky Way. The Magellanic Clouds were known to the Polynesians and Maori and served as important navigational markers. They're named after the Portuguese navigator Ferdinand Magellan, who was the first European to sight them during the first circumnavigation of the Earth between 1519 and 1522. Magellan never completed the voyage. He was killed in the Philippines during the Battle of Mactan. The Large Magellanic Cloud is about 163,000 light-years away. Although it looks like an irregular dwarf galaxy, astronomers classify it as a disrupted barred spiral galaxy. In other words, it started out very similar in appearance to our own Milky Way. It's about 14,000 light-years in diameter. It contains about 10 billion times the mass of the Sun. Its companion, the Small Magellanic Cloud, slightly lower and to the west, and it's located a bit further away, some 200,000 light-years distant. It's classified as an irregular dwarf galaxy, about 7,000 light-years wide, with about 7 billion times the mass of the Sun. Astronomers speculate that the Small Magellanic Cloud was also once a barred spiral galaxy, but it's become so disrupted by the gravitational tidal perturbations of the Milky Way, it's lost any resemblance to that appearance. The two dwarf galaxies are separated by about 75,000 light-years. They were considered the closest galaxies to the Milky Way until the 1994 discovery of the Sagittarius Dwarf Elliptical Galaxy, and then the 2003 confirmation that the Canis Major Dwarf Galaxy is actually our nearest galactic neighbour. The total mass of the Magellanic Clouds remains uncertain. Only a fraction of their gas seems to have coalesced into stars, and they probably both have very large dark matter halos. Both Magellanic Clouds have been greatly distorted by gravitational tidal interactions as they're gradually being torn apart and absorbed into the Milky Way. But gravity isn't a one-way street, and the combined gravitational force of both Magellanic Clouds is affecting the Milky Way as well, distorting the outer parts of the galactic disk. Scientists believe the Large Magellanic Cloud crossed the Milky Way's boundary about 700 million years ago, recent by cosmological standards. And due to its large dark matter content, it strongly upset our galaxy's fabric and motion as it fell in. These effects are still being witnessed today and should force a revision of how our galaxy evolved. Astronomers used a sophisticated statistical model to determine the speed of the Milky Way's most distant stars and therefore determine how the Large Magellanic Cloud has warped the Milky Way's motion. The findings, reported in the journal Nature Astronomy, suggest that the enormous attraction of the Large Magellanic Cloud's dark matter halo is pulling and twisting the Milky Way's disk at 32 km per second, or about 115,200 km per hour, towards the constellation Pegasus. To their surprise, they've also found that the Milky Way isn't moving towards the Large Magellanic Cloud's current location, as previously thought, but towards a point in its past trajectory. They believe this is because the Large Magellanic Cloud, powered by its massive gravitational force, is moving away from the Milky Way at an even faster speed of 370 km per second, around 1.3 million km per hour. This discovery will help scientists develop new modelling techniques that capture the strong dynamic interplay between the two galaxies. Astronomers now intend to find out the direction from which the Large Magellanic Cloud first fell into the Milky Way and the exact time that happened. This should reveal the amount and distribution of dark matter in both the Milky Way and Large Magellanic Cloud in unprecedented detail. The study's lead author, Dr. Michael Peterson from the University of Edinburgh, says the new findings beg for a new generation of Milky Way models which better describe the evolution of our galaxy. Astronomers were able to show that stars at incredibly large distances, up to 300,000 light-years away, retain a memory of the Milky Way structure before the Large Magellanic Cloud fell in. And this formed the backdrop against which they could measure the stellar disk flying through space, pulled by the gravitational force of the Large Magellanic Cloud. The discovery breaks the idea that the Milky Way is in some sort of equilibrium state. Instead, we find that the recent infall of the Large Magellanic Cloud is causing violent perturbations onto the Milky Way. And understanding these will give astronomers an unparalleled view of the distribution of dark matter in both galaxies. This is SpaceTime. Still to come, Washington launches a new top-secret spy satellite, but mystery surrounds exactly what it is they've flown. And the December solstice, the Geminids meteor shower, and the ticking time bomb known as Eta Carinae are among the highlights of December Skywatch. All that and more still to come on SpaceTime. The United Launch Alliance has successfully launched an Atlas V rocket carrying the highly secretive National Reconnaissance Office NROL-101 mission into orbit. The flight from Space Launch Complex 41 at the Cape Canaveral Air Force Station in Florida had been delayed several days, first by a malfunctioning liquid oxygen valve on the pad affecting LOX fueling operations, and then by worsening weather conditions due to Hurricane Eta. The 60-metre tall Atlas V launch vehicle was in its 231 configuration, with 3 strap-on solid rocket boosters. But this mission saw the first use of Northrop Grumman's new GEM 63 solid rocket boosters, replacing the Aerojet Rocketdyne boosters normally used. A stretched version of these new SRBs, known as the GEM 63 XL, will be a regular feature of the United Launch Alliance's new Vulcan rocket, which will start replacing the Atlas V from next year. Although details of the clandestine payload remain classified, this specific configuration is designed to carry 15.5 tons into low Earth orbit. Another clue comes from NOTAMs, that is, Notice to Airmen warnings given to pilots before a launch. These tell us the mission flew in a northeasterly track from Cape Canaveral, resulting in the spacecraft being placed into a non-polar inclined orbit. Now, the National Reconnaissance Office operates trumpet signals intelligence satellites and quasar communications satellites in elliptical Molniya orbits. These are inclined to give maximum dwell time over polar regions. They also operate stealthy MISTY imaging satellites and Intruder Naval Ocean Surveillance System or NOS ocean surveillance satellites in 65 and 63.4 degree inclination low Earth orbits. Further clues about the likely payload are provided by the sort of fairing used. In this case, it was big, 5.4 metres in diameter and 23.4 metres long, indicating a fairly large satellite, or possibly 2 small ones. This is SpaceTime. The December solstice, the Geminids meteor shower, and the ticking time bomb known as Eta Carinae are among the highlights of December Skywatch. And time now to turn our eyes to the skies with December Skywatch. December is the 12th and final month of the year in both the Julian and Gregorian calendars. December got its name from the Latin word decim, meaning 10. That's because it was originally the 10th month of the year in the old calendar of Romulus, which began in March. This year, the December solstice will occur at 21:02 Australian Eastern Daylight Time on the evening of Monday, December the 21st, when the sun reaches zenith, appearing to be directly over the Tropic of Capricorn. Now that's 5:02 in the morning US Eastern Standard Time and 10:02 AM Greenwich Mean Time. In the Northern Hemisphere, it's the winter solstice, marking the first day of winter. But the good news is that from now on the days start to get longer again. South of the equator, it means summer has well and truly arrived. On the day of the December solstice, Earth's south pole is tilted towards the sun. The sun rises south of east and sets south of west, reaching its most southerly declination of 23.4 degrees. Now, it's important to remember that the seasons are governed by the tilt of Earth's axis as it journeys around the sun in a year. A common misperception is that Earth's solstices, and consequently its seasons, also mark when Earth's nearest the sun. In actual fact, Earth's closest orbital position, known as perihelion, occurs about 2 weeks after the December solstice, and it's furthest from the sun at aphelion about 2 weeks after the June solstice. The next perihelion will occur on Sunday, January the 3rd, 2021, at 10 to 1 in the morning Australian Eastern Daylight Time, when the Earth will be precisely 147,093,163 kilometres from the Sun. Now that's happening at 8:50 in the morning on January the 2nd, US Eastern Standard Time, and 13:50 in the afternoon on January the 2nd, Greenwich Mean Time. As I mentioned earlier, temperatures on Earth are not determined by Earth's orbital distance from the Sun, but rather the angle of the Sun's rays striking the Earth. In summer, the Sun is high in the sky, and the rays hit the Earth at a steep angle. In winter, the Sun's lower in the sky, and the rays strike the surface at a more shallow angle. In most parts of the world, the seasons begin on the day of the solstice or equinox. However, Australia is a bit weird. Here, seasons begin on the first day of a particular calendar month: March for autumn, June for winter, September for spring, and the 1st of December for summer. Okay, let's start our tour of the night skies of December in the west, where midway up from the horizon is Fomalhaut, the brightest star in the constellation Pisces Austrinus, the southern fish. Fomalhaut is a young white spectral type A main sequence star. It's about 1.8 times the diameter of the Sun and is located just 25 light-years away. A light-year is about 10 trillion kilometres. The distance a photon can travel in a year at 300,000 kilometres per second, which is the speed of light in a vacuum and the ultimate speed limit in the universe. In 2008, astronomers discovered planets orbiting around Fomalhaut. It's not known if anyone was looking back. Main sequence stars are stars undergoing hydrogen fusion into helium in their core, the process which makes stars shine. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, then spectral type G yellow stars. By the way, that's where our Sun fits in. Then there are spectral type K orange stars, and the coolest and least massive stars are referred to as spectral type M red stars. Each spectral classification is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then there's a Roman numeral you add to that to represent luminosity, thus giving you a full description of a star. So, our Sun is technically classified as a spectral type G2V or G25 yellow dwarf star. Now, also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red stars but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are around 75 to 80 times the mass of Jupiter, or to put that another way, about 0.08 solar masses. Now, turning to the left of Fomalhaut is Achernar, or Alpha Eridani, the brightest star in the constellation of Eridanus the river. Located around 139 light-years away, Achernar has about 7 times the diameter of the Sun and rotates some 15 times faster. The effect of this rapid spinning is that the star flattens at the top and bottom, but bulges in the middle, giving it an oblate shape, sort of like the silhouette of a gridiron or rugby football. In fact, its equatorial diameter is about 50% greater than its polar diameter. Achernar is actually part of a multiple star system, Alpha Eridani A and Alpha Eridani B. The primary star, Alpha Eridani A, is a hot blue spectral type B main sequence star, while its smaller companion, Alpha Eridani B, is the spectral type A white dwarf star we were talking about earlier. The pair orbit each other at a distance of about 12 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres, or 8.3 light minutes. Moving further left from Achernar now, and just above the horizon, you'll see the bright star Canopus. It's the brightest star in the southern constellation of Carina the Keel, and the second brightest star in the night sky after Sirius. Canopus is a white giant star nearing the end of its life. It's located around 310 light-years away. It has about 8.5 times the mass of the Sun, but has expanded out to some 71 times the Sun's diameter. Canopus is some 1,300 times as bright as the Sun, and is, in fact, the brightest star within 700 light-years of the Earth. Its name originates in mythology from the time of the Trojan Wars and the navigator of Menelaus, the king of Sparta. Located between Canopus and the Southern Cross in Carina, in the Trumpler 16 open star cluster, is the ticking time bomb called Eta Carinae, a pair of huge blue, highly luminous spectral type O hypergiant stars. They're undergoing what's believed to be the violent final phase of their existence, before ultimately exploding as massive core collapse supernovae, stellar explosions so bright they'll outshine the entire galaxy. The binary system is located some 7,500 light-years away, buried deep in the Great Nebulae of Carina, a massive cloud of gas and dust stretching from 6.5 to 10,000 light-years away. The primary star in Eta Carinae is estimated to be around 150 to 200 times the mass of the Sun, with an incredible 5 million times the Sun's luminosity, 800 times its radius, and a surface temperature of up to 32,500 Kelvin. This is the only star known to produce ultraviolet laser emissions. The companion star, although smaller than the primary at just 80 solar masses and 20 times the Sun's radius, is even hotter, with surface temperatures of around 37,200 Kelvin. These two incredible stars orbit each other every 5.54 Earth years, cocooned in a gigantic twin-lobed cloud of gas and dust known as the Homunculus Emission and Reflection Nebula. This nebula was created when Eta Carinae underwent a spectacular eruption starting in 1837. Known as the Great Eruption, it eventually reached its peak in 1843, when it was one of the brightest objects in the night sky, before gradually fading away again by 1856. Eta Carinae underwent another slightly smaller eruption in 1892, and it's again been steadily brightening since about 1940. Eta Carinae and its surrounding shroud of gas and dust generate huge amounts of infrared radiation, making it the brightest known infrared source in the sky. As we said earlier, both stars are now reaching the end of their lives on the main sequence, and are expected to go supernova any day now. Of course, in astronomical terms, any day now could mean tomorrow, or it could mean in 1 million years from now. No one knows exactly when Eta Carinae will go supernova. Now, if the star has a low metallicity composition, it could collapse directly into a stellar mass black hole, and there'd be no visible explosion, or maybe a subluminous supernova, and a small fraction of such stars could produce a parent stability supernova. But at solar metallicity and above, there should be sufficient mass loss before collapse to allow a visible supernova to occur. Okay, let's turn to the east now, and looking just above the horizon, you'll find the star that outshines Canopus to take the title of the brightest star in the night sky. It is, of course, the dog star Sirius. And next to it, in the northeastern sky, just above the horizon this time of year, is the constellation Orion the Hunter, heralding the arrival of summer in the southern hemisphere and winter in the northern hemisphere. One of the astronomical highlights of December is the annual Geminids meteor shower, which usually peaks around December the 13th and 14th. Radiating out from the direction of the constellation Gemini, the Geminids are unusual in that they're not generated by a comet as most other meteor showers are, but they're produced by the debris trail left behind by the asteroid 3200 Phaeton. That makes the Geminids, together with the Quadrantids, the only major meteor showers not originating from a comet. Still, Phaeton's high orbital eccentricity does more closely resemble that of a comet than an asteroid. And it may in fact be an ancient comet that's run out of the volatile gases that characterize a normal comet by producing their iconic cormorant tails. Because of this, many astronomers classify Phaeton as a rock comet. The Geminids usually have a yellowish hue and tend to be a bit larger and more solid than typical meteors from comets. In the northern hemisphere, expect to see up to 120 meteors an hour between midnight and 4 a.m, but only from dark skies. Well north of the equator, the radiant rises at about sunset, reaching a usable elevation from local evening hours onwards. In the southern hemisphere, you won't see nearly as many meteors, maybe 10 to 20 an hour. That's because the radiant won't rise above the horizon. Now, for listeners in the northern hemisphere, there's a second meteor shower in December, the Perseids, radiating out from Ursa Minor, the Little Dipper. The Perseids are generated by debris left behind by the comet 8P Tuttle. They're a compact stream, peaking on the night of December 22nd and the early morning hours of December the 23rd. Just look towards the bowl of the Big Dipper and you'll probably see around 10 meteors an hour. Now, for the rest of the December night skies, we're joined by Jonathan Nally, the editor of Australian Sky and Telescope magazine.
Well, let's start in the middle of the evening, right, when most people get out and do their night sky viewing, right, before it gets too late. It's nice and warm. It's summertime now down here in the southern hemisphere, of course, so beautiful time for stargazing. And even though the nights are shorter because we've got more hours of daylight because it's summer, the weather's pretty good and lots of good things to see up in the night sky, including in the middle of the evening, you've got the Milky Way, which is stretching all the way across the eastern sky from south to the north. And starting down the south, the Southern Cross, which is one of the constellations everyone wants to see, well, it's upside down at the moment and it's right down on the horizon. So depending on where you are, you might not even see it. So if you're around the latitude of Sydney, then if you've got a clear horizon, which means you don't have any buildings and trees and hills and things away, then you'll see the Southern Cross upside down, sort of right on the horizon. If you're further down south, if you're in Melbourne, then you get a better view. The cross will appear to be higher. It'll be up above the horizon a bit. But if you're way up in Brisbane or something, then you're not going to see the cross because it'll be below the horizon from where you are. You have to wait for later in the night, and the Southern Cross will start to pop its head up above the southern horizon a little bit east of south. Okay, so that's down the southern part of the Milky Way at this time of the year. And if you've got dark skies too, you should be able to make out the two nearest galaxies to our own. We talk about these quite a lot on the show. The Large and Small Magellanic Clouds. They're nice and high actually at the moment. The Southern Cross is down low, but the Magellanic Clouds are up nice and high down in the south. They just look like two faint fuzzy clouds. So if you have a night sky that doesn't have any clouds in it, nice clear sky, if you do see two fuzzy things down in the south, that's the Large and Small Magellanic Clouds. Each of them are galaxies in their own right, and they've got millions of stars. Around to the east or left, as you're looking at it, of the Magellanic or the Large Magellanic Cloud, you've got a bright star, and that's star Canopus, and it's the second brightest star in the night sky. And if you go still further around to the east, around to the left, you'll come across an even brighter star. That's called Sirius. That's known as the Dog Star because the constellation that it's within is called Canis Major, or the Greater Dog. There's also a nearby constellation Canis Minor, the Lesser Dog, and its bright star is called Procyon. Still in the eastern sky, about halfway up from the horizon in the mid-evening this time of year, Stuart Gary's favourite constellation, mine too, I suppose, is Orion the Hunter. Lots of people's favourite, actually. You just can't miss it. We speak about it all the time, don't we, this time of year? With its three middle stars in a row forming the Hunter's Belt, and above and below you've got the belt, you've got the sword, and you've got the stars Rigel and Betelgeuse. There, it's just really glorious. Now, if you keep going further around to the left from Orion, so you're sort of heading towards the north now, you should see a reddish sort of star and a sort of triangle or wedge of stars just beside it. Well, that star is called Aldebaran, and the triangle of stars just next to it is called is a star cluster called the Hyades, right? And it looks really beautiful. Get a pair of binoculars onto it, and it's all these little glittering stars in this beautiful little cluster. It's a really lovely part of the night sky. So any binoculars, even small ones, have a look at it, and you'll be knocked out, really. Still going around to the left from the Hyades, you go around further around. We're sort of heading towards the west now. There's another smaller, but in a way more prominent and even better star cluster, and it's called the Pleiades, also known as the Seven Sisters. So called because most people from dark skies, if you've got normal eyesight, not like mine, I need glasses, if you've got normal eyesight, you'll be able to see 7 stars. Some people have claimed to see up to 11 stars with the naked eye in this little group. There's actually about 1,000 stars in this star cluster, but you can't see all of those, of course, with the naked eye. But again, get a pair of binoculars onto it and you'll see dozens of stars. And they're these bright little pinpricks. They're really, really beautiful. If you get a telescope on, you'll see even more. And if you have a look at pictures on the internet of the Pleiades star cluster, you'll see that these stars seem to be enveloped in this beautiful blue wispy nebulosity. It looks really, really beautiful. It's a fantastic little group of stars. The nebulosity and the star cluster itself are separate. They just happen to be in the same line of sight. It used to be thought they were together, but no, now they're separate. Incidentally, in Japan, this little group of stars, the Pleiades or Seven Sisters, is known as Subaru. Their name for it is Subaru. If you take a look at the badge on the front of any Subaru car, you'll see that badge for Subaru is a little group of stars, the Pleiades on the Subaru cars. Have a look next time you go past one.
Indeed. One of the amazing things about the Pleiades is also the fact that it's known as the Seven Sisters or Seven Women all over the world. These are communities that haven't had anything to do with each other for thousands of years, yet they all collectively still refer to the same grouping of stars, the same open cluster, as being seven women or seven sisters or something along those lines.
Yep, they do. Well, I don't actually, I was thinking about this earlier on today, actually, and I don't know how many of these communities around the world have come up with that same sort of idea. Typically, when things are pretty in the night sky, they're sort of given feminine names. Even Venus, right? It's bright and lovely and big and bold and everything. And of course, that's named after Aphrodite and all those sort of people. So the Seven Sisters, yes, is known by different communities and spread around the world as I say, Seven Sisters or Seven Women or Seven Girls or whatever. But I imagine, as I say, I was thinking about this today. I must look it up. I imagine that there are probably dozens and dozens and dozens of other communities who didn't name the Pleiades.
Yes, a confirmation bias at play.
Yeah. So it's amazing how coincident some have, but if all the rest haven't, well, what does that say? So, but it still is interesting that some did. So, no, you're absolutely right. Well, let's have a look at the planets. Got some interesting stuff with the planets. So Venus at the moment is visible to the east in the pre-dawn sky, so you've got to be up early, and you just can't miss it. It's out there to the east, which is the direction where the sun comes up, big and bright. It's the biggest and brightest thing out there. So have a look at Venus. It's really lovely. Mars, the red planet, that's in the evening sky. So you can see that in the northern part of the sky. It's seen from the southern hemisphere. It's in a pretty bare patch of the sky as far as stars are concerned, but that actually makes it even easier to identify in a way because you can't really miss it. It's a medium brightness, orangey red sort of dot of light. Looks like a star, but it's actually the planet Mars. Now, Jupiter and Saturn. This month, Jupiter and Saturn, really big, really
special,
big.
Very special, right?
Very special. Well, it's going to be amazing in December. So they start the month close together in the western half of the sky after the sun sets. And again, you can't miss them because Jupiter's really big and bright and Saturn is right next to it. And as the days go on, they'll get closer and closer and closer together as seen from Earth. It's just a line of sight effect. They're not actually close together in space. They're hundreds of millions of kilometres apart in space. But from our perspective here on Earth, they seem to be coming together. Until on December the 21st, they'll come to their minimum separation or maximum closeness, if you like. They'll only be a tenth of a degree apart. Tenth of a degree. Now, this is pretty amazing. That means that anyone with a telescope will be able to see both planets in the same field of view at the same time, which you rarely ever get a chance to see. I mean, almost never, in fact. In fact, looking at the calculations, this sort of close approach of these two planets this month is the closest they'll have been to each other as seen from the Earth since the year 1623, believe it or not.
I remember
400 odd years. You remember that, do you? But back in 1623, however, you probably wouldn't have been able to see them because they were together, but they were really deep in the evening twilight glare, so they would have been very, very hard to see. The last time when they would have been easier to see, when they would have been further away from the glare of the sun and therefore viewable in a dark sky after the sun had gone down, well, that would have been the year 1226. Kid you not. So don't miss this opportunity. I don't know when they're going to be this close together again in the future, but based on those sort of dates, it's going to be hundreds of years probably. So this is one of those once-in-a-lifetime things. I mean, if you go out there and you think, it's just two planets close together, whatever, but when you think you'll never see this again, it's going to be pretty specky, particularly if you've got a pair of binoculars even, or someone's got a telescope that can give you a look. It's going to be really, really spectacular. As I say, you won't have trouble spotting them because Jupiter out there in the western sky after sunset is big and bright, and Saturn's going to be right next to it. So give that a go, folks. With a good
set of backyard binoculars or a telescope, you may even get to spot some of Jupiter's moons.
Oh, look, any little binoculars will do that for you. I used to, when I was first getting into astronomy, I only had a little pair of 8x40 binoculars, which is fairly small. And you could see the moons of Jupiter. Now, when we say you could see the moons of Jupiter, they didn't look like moons. They just looked like little tiny pinpricks of light, like little tiny stars. But if you take a look at them and you go away and you come back 6 hours later, you'll see that they've moved because they're circling around Jupiter. And that's, of course, the famous observation that Galileo made all those years ago, where he, for the first time ever, he saw people saw that there were things moving around other things out there in space, which sort of set in train the scientific revolution, if you like, by showing that Earth wasn't the centre of everything. Everything out there in space didn't revolve around the Earth, because look, there's stuff going around Jupiter. And there's stuff going around Jupiter, then what else is out there?
And yet it moves.
Yep. So look, it's wonderful how you can connect things just by making little observations. So that sort of thing, having a look at the moons of Jupiter and seeing these two planets very close together in December hasn't been seen for hundreds and hundreds and hundreds of years like this. So please, if you've got some clear skies, go out and have a look. You'll be glad you did.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.